my name is Benjamin and welcome back to my channel, Learn a Lot. If you have not subscribed, yes, this is the time to do it. Subscribe and hit like, comment and share. Remember the last time we used only, I think we used only 3 different images, but in this case we're using 32 images, and that's a lot of data. In those 3 images in the previous tutorial, what we did was we wrote a single code, a single line code where we combine the rasters at the same time as we're converting them from lists to raster. But this time around, we're going to have to go through all the images one by one and convert it to raster, then combine them as a stack. So if we do those steps separately, we're going to have a long line of code, which is going to take us a lot of time typing. But instead of doing that, we're going to use for loops to loop through all our images and then convert them to raster and then stack them together. Remember, when we load the images like I showed you here in the function file, you load them as list files, so they are not going to be used as rasters if they are in this format. So you need to convert them to raster, but when you do that, you do that one image at a time. That's why we need a for loop, so that we do that every single time that we're loading a certain image. So to do that, we're going to write another for loop. So we're going to say from I in 1, since we know that we're using 32 images, we're going to go ahead and type from 1 to 32. So we're going to go through each image from 1 to 32. And for the first case, we're going to say if I is equal to 1, that's the first image. That's the first image. If I is equal to 1, then we're going to say, let's give our image, let's convert the first image that we pull to raster, and that image, let's say we're taking it from images of Ben3, so that's the first image. We convert it to raster. We're converting it to raster, right? So once we convert that to raster, I want to do the cropping at the same time as well. So I'm going to say B3 will be equal to crop, of which you can actually write this as one line. Ben3, you put the crop. Let me show you what I'm talking about. Instead of having 2 different lines, then you can put these things together so that you don't have too much to work with. So you're just gonna say, as you convert this thing, the first image to raster, you want to crop it as well, so that you are able to use your small image instead of having way too many images that you'll be using at the same time. So else, if we on the second image going up, then what we'll need is not just to crop these images, but we'll also need to stack them together. So we're gonna do this. We're gonna say, because here we want to start stacking them as we're cropping them. So we're gonna say Ben3. If you don't understand what I'm doing with the stacking and the cropping, I suggest you look at the previous video. That will show you how this process is done. Now, this is one thing I want to explain here. Ben3 at this point, once you run this code, the first layer that you pull will be cropped using your shape that we loaded in the function, the shape file, which is our area of interest. Then you're going to crop it and save it into Ben3. In the next step, once you start doing this, you are replacing this Ben3 with a new variable called Ben3. So Ben3 will be replaced by this Ben3, which is an empty file now. But what are we storing in this Ben3? We are storing the previous B3 that we created, and then we are stacking together to it the new image that we want to crop. So instead of having 4 different lines that do this, we're just going to have these 2 that will run this model for us without any issues. So we're going to test to see if our model worked perfectly. Then we run that. Yeah, that's fine. So, all right. So That function worked perfectly like a charm, so we're just gonna say bend3 to see if our layers were cropped properly. There we go. We've got all of our layers in there. We can check the descriptions like we did last time. So bend3 has got 32 images in there, so our crop was fine. We're gonna repeat the same thing for the bend8. We're just gonna change here to 8, here to 8, since it's the same thing. Or else, you know what is actually smart, I just didn't think about it until now that I'm doing this, is we could have embedded these two things at the same time in that same function, right? I'm just going to show you right now. I'm going to run this. Okay, so our function ran perfectly as well, so we can verify that by saying b8. As you can see, we also have 32 images. So a better way to do this would just be for us to, I don't know why I didn't think about this, it's stupid, to just put those two lines there. Then it saves us time. So when you're running that function, it runs for both of them at the same time. Just bear in mind that when you're running a lot of files, it might take a while for it to run and get to where you want it to get to. So now that we have two different stacked images of bend3 and bend8, remember when you're running your NDVI, you just need to put one image as an input. So we're going to stack these two images together. I'm going to go ahead and say image and then say stack. Then we're going to say bend3, right? We're starting with bend3. Bend3 and bend8, let's say. Okay. Bend3 and bend8. We're just going to make sure when you're doing the NDVI we do the right thing. Then we run that. This should go quicker. There we go. So now that we've got these, so you can actually go ahead and try and plot these images to see what's going on. So you can actually say, let's plot bend3 first. B3. So you can say I want to plot images from 1 to 10. No man, sorry, it's not what I wanted to do. I think I missed one bracket. So you can see that when you do this, it plots for you all the 10 images you requested. So if you specify up to 32, it's going to plot the 32 images. One thing that you need to pay attention to now is that when you're plotting an image, you must make sure you put double braces. If you put one braces, it's going to start plotting the actual values, the pixel values in your image, which is another different way of starting to use your pixel values, but I prefer the method I'm going to show you just in a moment. So we see that we've got our images. Now we're going to run our NDVI, and we're going to say NDVI is equal to NDVI. Okay, this is what I just remembered. We're looking at NDVI at multiple levels, so I'll need to write that function. Remember we had a function we used last time, but it's gonna be basically a function that is similar to yeah, exactly. I think it's exactly the function we used last time, so I'm just gonna copy that function here to save time because we already explained the function the last time. Remember in the last tutorial it was 3 there. You can revisit the last tutorial so that you see what I'm doing here. But now I'm using 32 because now we've got 32 images for each bend3. Now remember, we have 32 images of bend3 and 32 images of bend8. When you stack them together, that gives us 64 images. Bend8 start at 33, while bend3 starts at 1. So from 1 to 32 is bend3. From 33 to 64, that's bend8. So for every time that we're running this NDVI, we want it to start taking our first image as at the 33rd image minus the first image over the summation. Remember the formula of the NDVI. So this should be able to give us what we want, right? So we're going to have the result should be stacked image of NDVI values of 32 different NDVI images. That should be our expected result. Okay, so we already got our results. Now I'm gonna plot our NDVI so that we see what we got. We say from 1 to 15. Let's plot 15 images and see if we got something honorable, some honorable results. So let's see what do you have. There we go, 15 images. So we can zoom into this to see what we are working with. So you see that we've got about 15 images of NDVI calculated. So you can see, for example, in this case, we've got a lot of vegetation here. All the greens, that's vegetation. And then the brown or the yellow parts, that's base soil. And then this is the Cat River Dam, right? So that's like below zero values. So you can see we've got a lot of base soil here, which might indicate that there was drought in this period, even in this time as well. Those are indication, and we can look at that at some later point. Let's see, dark mode. When we zoom in, does it zoom it in dark mode? Interesting, nice. So yeah, now that we've plotted our images, so we want to start getting pixel values. Remember, we already done this in the previous tutorial. So what I'm gonna do is the only difference between what we're doing now and the previous tutorial is the fact that we including for loops to loop through different multiple images, which is a plus to the tutorial that we did last time. The fun things that we're gonna do with this session, sorry, with this particular tutorial, is when we start doing the actual change detection using numerical values, and then we're gonna do a bit of principal component analysis. Then we're gonna see what the numerical opinion is on whether there has been changes or not, and if that can be a valuable tool you can use in your research or whatever projects that you are involved in. So this is it for this tutorial. Thanks for watching. Let's meet in the next tutorial where we will look at how we can extract pixel values and construct tables that we can use to plot our bar plot. Stick with me until we reach the point where we do actual change detection. So thanks for watching again. Ciao. Let's meet on the next video.